Hi students, I'm going to work through this question from our practice questions on page 137 of the Hebden textbook. It's question number 35, a really good question for pulling together concepts about excess reagents and limiting reagents, figuring out how to calculate percentage yield. And then also question B asks us, okay, if we know how much reactant we actually used and how much was available at the start, can we figure out what was the excess, what didn't get used? So this is a great question for pulling all this information together, and it's a good review. So let's do this together. I'm going to work through it a bit slowly just because my pen is not, I got to write it slowly so it's clear. And so we've got this reaction. It's benzene, so C6, H6, that's benzene, plus excess nitric acid in this nitrating solution, so HNO3, gives us, and again, sorry about my pen, I'll do my best here to write clearly, but sometimes it doesn't work very well. Okay, gives us this product C6H5NO2. So C6H5 NO2 plus some water as a product. Okay, so you're given this reaction equation, and then you're told a little bit of information. So you're told that you have 25 mils of the benzene, okay, and you're also told the density. So let's write that information down. So we've got underneath it, I've got, actually I'm going to write this over here to the side. So I've got my benzene, this is C6H6. Okay, this is what I know. I have 25 mils of this stuff. And I also know that it has a density equal to 0.879 grams per mil. That's a 9. Okay. So we know that information. We also are told that the product, C6H5NO2, we get 18 mils of that. So let's think about that for a minute. This is what we have over here. So C6H5NO2. Okay, so we end up with 18 mils of this. And our density is given to us in the question. And this guy has a density of 1.204 grams per mil. Okay. So, by the way, this is a decimal place right here. A little bit of trouble with my pen today. Okay, so first things first, let's think about what we have in this reaction. We're told a little bit of information. Like, for example, over here, this guy is our product, right? This is our product. Okay, and then this is our benzene over here, C6H6. It's our limiting reagent, we're told that. And also, the first thing we want to do before we even get going with this is make sure that this reaction equation is balanced. So that would be my first step. Always, I want to just check and ask yourself, is the reaction equation balanced? And I'm really sorry about my pen. Okay, so in this case, if we look at the carbon, we've got 6 on the left-hand side on the reactant side, 6 on the product side, so carbon looks good. Let's look at nitrogen. 1 here on the left side, 1 on the right side. Oxygens, I would look at my oxygens next. On the left side I have 3 in the HNO3, but on the right hand side I have 3 as well, because I've got 1 from the water and then I've got 2 from the product. So my oxygen is balanced. Hydrogen also looks good. I've got on the left hand side I've got 6 plus 1 is 7. On the right hand side, again, I've got 5 in that product and 2 from the water is 7. So this is balanced, so we don't need to do any balancing. That's nice. Okay, if it wasn't balanced, we'd have to balance it first. It's going to be important in any of these types of reactions where we have stoichiometry, because if the coefficients in the front aren't correct, if we need to use a mole ratio or cross the mole bridge, our answer is going to be wrong. We're going to have the wrong mole ratio, so that's really important. Second thing we need to do is wrap our head around, okay, well, what's this question asking? So this first question in 35A asks us to find the percent yield. So to do that, we first need to figure out how much product did we make here, okay? That's going to be important. So how much product did we make? We're told we got 18 mils of it, and we know the density. So we can actually figure out using the density here and the volume how many grams we actually made of our product. that's going to be what we do next. We're going to find, so let's find the actual mass of product. Okay, we're also going to have to find the theoretical mass starting with our reactant, our benzene, crossing the molar bridge over to products to figure out how many grams of product I should have made if I started off with 25 mils of benzene. Okay, so that's going to come soon. This is going to be a long question, so I'm going to have to go back and forth on my page a little bit. Just bear with me, please. Okay, so let's go ahead and let's do some work here. So let's find the actual mass of product. What we're going to do here, we're given, if I go up a little bit here, we are given the mils of product and we're given the density of product. So we're going to have to change. We're going to have to change from mils into grams in order to calculate this. Okay, so let's go ahead and do that. So the grams of, I'm going to use a blue pen for this, the grams of C6H5NO2 okay, is equal to 18 mils, right? And now we need to convert into grams, so we're going to use this density, making sure that I have my gram on the top and my mils on the bottom so that the mils cancel. So I put 1.204 grams in the top, and the 1, that's per 1 mil, right? So my mils are going to cancel. So now I actually have an answer in grams, and my answer is going to be 21.672 grams. Keep track of our sig figs, but let's not round yet, okay? In this answer, we should be allowed to have 3 sig figs because we had 3 from the 18 mils and 3 from the density. So let's just go ahead and underline those 3. Okay, notice that I don't round this up to 21.7. Don't do that. Keep your digits, underline your sig figs so you keep track of them. We want to have, we don't want to introduce rounding errors because I've still got more calculations left to do. All right, so that's thinking about what this is. That's the actual mass of product. That's how much product I actually made. Okay, the next step is I need to figure out how much product should I have made if I started off with 25 mils of benzene. Now, I'm going to break this into 2 steps. I could start with a volume of benzene and convert into grams of benzene. Then I could cross the molar bridge over to my product and then change over to grams of product. That's fine. You could do it that way. I noticed that in question B, I'm just thinking a little bit about what kind of information I need for this question. And I noticed that B is going to ask me to figure out how much excess benzene reactant I had. So I'm actually going to break this up. And first, I'm going to figure out how many grams of benzene did I start with. That's, rather than use the 25 mils, I want to change that into grams. Then I'm going to do a calculation and change from my grams of my reactant over to my grams of my product. Okay, so I'm going to break this into two different questions. So 3, okay, I'm going to say let's find the grams of benzene used, or the mass. Okay, this is my reactant this time. So let's find, and actually let's call this the mass of reactant at the start. Okay. So I want to know how much was that if I had 25 mils of benzene. How many grams was that? So I can go ahead and do the exact same type of calculation here, except this time I'm going to be using the mass and the volume of benzene. So I've got my grams of benzene, so we're looking at C6H6 here. Okay, it's going to be equal to 25 mils. Decimal place there. This time I'm using the mass of benzene, and it's going to be 0.879 grams per mil I put that conversion factor in that way because I want to cancel my mils and I want my answer to be in grams. So that's what leads my units there. And my answer comes out to be 21.975. 21.975 grams. And again, sorry, 5. This pen is terrible. And I want to keep track of my sig figs. I'm allowed 3, so let's just underline those 3. So right up to the 9, okay? But not past the 9. But I don't want to go ahead and introduce a rounding error yet. So next step, okay, so now I know how much benzene I had to start with. I know how much product I actually made. To get a percent yield, I need to know how much product should I have made. So what is the theoretical mass of my product? So that's going to be my next step. I'm going to find the theoretical mass of the product because I have the actual mass. So let's go ahead and find the theoretical. Now remember, to find the theoretical, you start with how much limiting reagent you had. You cross the mole bridge to get into a different chemical species, so products, and then we can convert from moles of product to grams of product. So just to put this out, because this is often a hard step for students, thinking about what we're doing here, we're starting with grams of our reactant, okay, and then we need to get to moles of our reactant, and then we have to cross the mole bridge to get to moles of product, and then grams of product. So lots of steps here. This is a big calculation. Now we've kind of we've done a little bit of the work that we would have originally had to do, because in step 3 we figured out the mass of the reactant. So at least we don't have to start with 25 mils here. We can just go ahead and start with the actual grams of reactant, and then we're going to get into moles of reactant, moles of product, grams of product. So let's go ahead and do that calculation. So remember, we are eventually looking for the grams of product. That's what we're after. That's what we want. So it's the grams of C6, okay, H5NO2. And this is going to be a longer calculation. Bear with me here, okay? So we start with our grams of reactant. Well, we just figured that one out. It's 21.975 grams, okay? I'm going to go ahead and put in the actual formula. So C6H6. This is just to help you keep track, okay? So starting with grams of reactant, then I need to get to moles of reactant. So I need to use the molar mass of C6H6. Well, we haven't calculated that out yet, so let's do that right now. And I would recommend, I'm going to do it down below, but you might even want to do it at the beginning of your page. So let's find some molar masses, because these are helpful. Okay, well, the molar mass of C6H6, you've got 6 carbons, which have a mass of 12 each, plus 6 hydrogens, which have a mass of 1.0. Remember, we're getting these off our periodic table. So 6 times 12 plus 6 is 78.0 grams per mole, per 1 mole. Okay, now the molar mass, while we're at it, let's figure out the molar mass of our product as well, because we're going to need that in just a moment, right? So we've got, our product is C6H5NO2. Okay, and our molar mass of that, let's calculate that out. So you got 6 carbons. Carbon has a mass of 12 grams per mole, plus 5 hydrogens with a mass of 1 gram per mole, plus nitrogen, just 1, and nitrogen has a mass of 14, plus 2 oxygens, and oxygen has a mass of 16. So the mass of our product comes out to be equal to 123.0, what do we have our sig figs, grams per mole. Okay, so there are 2 molar masses. Okay, so let's come back up to our question for a minute now that we figured that out, and we're going to put in the molar mass of the benzene to get from grams to moles of benzene. So we've got, I want to make sure my 1 mole goes on the top. So 1 mole of C6H6 has a mass of 78 grams. hopefully your writing is better than mine as we do this. Okay, now I'm into moles. All right, next step, I need to cross the mole bridge. So I'm in benzene. Here's my mole bridge right here. I need to get over to product, from reactant to product. So that's where I go to my balanced reaction equation, and I use the mole ratio. So here, my reaction shows that I have a 1-to-1 ratio of the coefficients. So 1 mole to 1 mole. So that's easy. Okay, so for every 1 mole of my reactant, which is C6H6, I have 1 mole of my product, which is C6H5NO2. Now notice that I make sure, even if these weren't 1-to-1, right, I need to always be careful because I want to make sure that I'm canceling out of moles of reactant, so that goes across from moles of reactant in my conversion factor, so that those moles of reactant are canceling. Okay, now I'm in moles of my product, and finally I've got one more step to do. I'm going to have to do it down here. And I need to get out of moles of product into grams of product. I use my molar mass of my product, which I figured it out, it's 123 grams per mole. So I'm going to plug that in, making sure that I put the 1 mole on the bottom this time, right? Because I want to cancel out of moles and get into grams. So 123.0 grams goes on the top. All right, and then I cancel out of those moles of product. Now I'm in grams of product. So what is my answer? Okay, so I do all the math there, and my answer comes out to be 34.653 if I leave a few digits. Grams are my units, okay, and 3 sig figs are allowed, so I'll just underline those 3 sig figs. So this is how much product I actually should have made if all of my 25 mils of my benzene reactant were reacted in this reaction to form product. That's what I should have got. Okay, so I've got everything I need now to calculate part A. So I know my theoretical mass was 34.6 grams, and how much should I actually use if I come back here again? The actual mass was the first thing I calculated, was 21.6. So obviously I am going to have a less than 100% yield here. I didn't get as much product as I should have got if 100% of my limiting reactant had reacted. So let's go ahead and calculate out the what is that number. So percent yield, remember percent yield is how much you actually got over how much you should have got. So it's your actual mass of your product over your theoretical mass, how much you should have got it. Should have got, not got it. Okay, and then we times that by 100% to get our answer. So the actual mass, again, you got to go back, and that's nice if you have your calculations really clearly laid out. So 21.672 grams was how much I actually got, and I'm going to underline those sig figs. Okay, divided by 34.653 grams. Again, I'm going to underline those sig figs. Okay, times 100%. Remember, I'm underlining my sig figs so that I get the right number of sig figs in my answer, but I don't lose digits until the very end when I want to report an answer. So the percent yield is going to come out to be equal to 62.5. So when I do that division and I times by 100%, I get 62.5. When I round to 3 sig figs, my answer is a percentage. Okay, and my sig figs for this question should be 3 sig figs. Okay, great. So you've got the first part of it done. All right, part B. Let's look at part B right now. Part B asks us to figure out how much benzene was not reacted. So in other words, how much excess reactant was there? And just to remind us, the reactant was benzene, C6H6. Okay, so we're going to work backwards on this one. Remember that the excess, this is going to be our formula, right? Excess is equal to the mass at the start okay, minus the mass that was actually reacted. So we have almost all of this information, right? We know the mass at the start. We already figured that out. This one's done. Let's go ahead and just plug it in. So if I go back up, I've done a lot of work here today. Let's go back up and look at that. We figured it out, right? Here was the mass of the reactant at start right here. So it's 21.975 grams. Oopsie, sorry, 975 grams. And again, remember your sig figs, so I underlined 3 of those. And I need to figure out, well, how much did I actually react then? That we don't know. We know how much product we actually got. And in the same way, in the last question where we started with reactant and we crossed the Molar bridge to product, we can do the same thing working backwards now. We know exactly how much product we really made. So let's work backwards and cross the Molar bridge and figure out, well, how much reactant did you really react then? Okay, so this is going to be our calculation. We want to find the grams of benzene that were reacted. And so this time we're going to work backwards, and we're going to say, my plan is going to be, I'm going to go from my grams of product, that my actual grams of product, and I'm going to go and cross into moles of product by using the molar mass of the product. And then I can cross the mole bridge and go to moles of my reactant, and then my grams of reactant, okay? Using the molar mass. So this is a very similar calculation to the one we did a couple steps ago. So let's go ahead and do it. So grams of benzene is what we're looking for. The actual grams of benzene that were reacted. So you have to start with your mass of product, your actual mass of product. You can get this right from here if you want, or you can go back up to your calculations earlier. And you're looking for your actual mass of product, which was the first thing we calculated. So 21.672 grams. Okay, 21.672 grams of my product, and I'm going to be thorough and put the name of the product in here. Again, this is just to help you keep track. You don't have to put the formulas into your calculations if you don't want to. Now we're going to cross into moles of product, so we use that molar mass of our product, and we said that the molar mass was 123 grams per mole. So I'm going to make sure I put the 123 grams on the bottom so that the grams cancel, and my 1 mole is going to go on the top. Okay, great. Now I'm in moles of product. I'm going to cross the mole bridge. Remember, we have a 1-to-1 mole ratio. So for every 1 mole of reactant, C6H6, sorry, hard to read there. Okay, there's 1 mole of product, C6H5NO2. Okay, so the moles of, whoopsies. Okay, my moles of product have canceled, so I'm in moles of reactant now, and the last step, I don't have quite enough room here, is to go from moles of reactant now into grams of reactant. So I'm going to use the molar mass of benzene, and it's 78 grams per mole, putting my 78 grams on the top, my 1 mole on the bottom, so that my moles, my moles cancel. And my answer is going to come out into grams. I do the math, it comes out to 13.743 grams. And again, 3 sig figs are allowed here. Keep track, but don't round. Okay, and now I can go ahead and plug that answer back in up here into my calculation. So 13.743. That was the mass that I actually reacted, 3 sig figs. And so my answer, I do this subtraction, it comes out to be 8.232 grams. Now let's think about our sig figs. This is subtraction, so we are going to round this to 1 decimal place. And so my answer is going to come out to be 8.2 grams because of the addition subtraction rule. So remember, my sig figs only allow 1 decimal place here in my answer. Now your textbook is going to report 8.23, and that is because they arrived at this answer. They showed 2 different ways of arriving, but one is actually they used a multiplication route in order to get to their answer, which is fine. You just have to follow the sig figs of whatever operations you're doing. So because in the way we solved this, we did do a subtraction, we are limited to 1 decimal place, and that's what we get. So 8.2 grams would be our answer for this. So we've solved quite a bit of two different questions, but lots of work, lots of thinking about what's going on in this reaction, and that's how we would approach this question. Best of luck.